Hey, how's it going? I'm going to work through the skill quiz on slope, rate of change, and unit rate. So hopefully, by the time I'm done, you'll have a much better understanding of what slope is, how to find slope, and how it links and relates to units, rates, and proportional relationships. All right, so first of all, if something has a constant rate of change, it makes a line. All right, so let me see here if I can make a line. So let me put arrows on both sides. All right. So if I have a line, it could go like that, up from left to right. It could go down from left to right. It could be horizontal or it can be vertical. Okay. All of those represent constant rates of change. All right. If it didn't have a constant rate of change, then it would curve. For example, this one starts off slow and then it goes up faster, right? Okay. Or this one is going down fast and then it slows down at the end, right? Okay. So these ones represent not constant rates of change, or maybe it goes up and then down and then up and then down. All right. So these are constant rates of change, and these are not constant rates of change. And again, when something has a constant rate of change, it is linear. And when something has a non-constant rate of change, it is nonlinear. All right, in other words, we get lines, and here we get curves. All right. When something has that constant rate of change, we can find that rate of change. It's the slope, okay? So slope is equal to the measure of the constant rate of change. And slope can be positive or negative or zero or undefined, okay? So this slope right here, because it goes up from left to right, is positive. This slope is negative. We didn't talk about these two. We'll talk about these later. This one has a slope of 0, and this one here has a slope that is undefined. Okay, so we're not worried about these two for right now, but we are talking about this one goes up from left to right. You know how we read a book from left to right? It's increasing from left to right, so it is positive. Okay, this one is decreasing from left to right, so it is negative. So slope is a measure of the constant rate of change. It's a measure of how steep the line is. The steeper the line, the greater the absolute value of the slope. So if it's going up steeper and steeper and steeper, for example, if I were to make this line right here, okay, that line is more steep, that line is less steep. So this one right here would have a greater absolute value, a greater slope. This one would have a lesser slope, all right? Now with negatives, because the greater the more negative the number, the smaller the value, we talk about absolute value. So this one is steeper, so its slope has a greater absolute value. It's going to be more negative, so the number itself is actually smaller. Okay, so slope only applies to a line which has a constant rate of change, and it's a measure of the steepness. And what we do is we measure it as rise over run, or the change in y over change in x. So slope is the change in y over the change in x. Sometimes, many times, we say rise over run. And I don't know if you've ever gone skiing or not, or snowboarding, but you know how they have like diamond and double diamond and things like that. All right, one of the things that makes it more difficult is if it is steeper, right? It has a greater slope. And if you think about what makes it steeper, it goes up faster, right? While it goes over less. So that compared to that, right? okay? So this one goes up really fast in a short amount of time. It is steeper, right? This one goes up. It takes a much more time to go the same distance up. In fact, it's not even up as high, so it is less steep. So this one's going to have a greater slope, and this one's going to have a lesser slope. Does that make sense? Okay. And we're going to measure it. This is the rise, and this is the run. This is the rise, and this is the run. This is my change in y. This is my change in x. This is my change in y. This is my change in x. Okay? From there to there, when I go up, I'm changing my y values. And when I go over, I'm changing my x values. Okay, so one of the mistakes I've seen on this quiz from a lot of people is they did the change in x over the change in y. Okay, and the reason they do that is because if you look at the table, x comes before y, right? X is above it. So if a lot of times people would want to do 16 over 6, but really we want to go the other way. Okay, change in y over change in x, rise over run. All right, and the other thing that you should know going forwards is slope is equivalent to the unit rate. All right, do you remember when we're finding the unit rate, we take the first quantity and we divide it by the second quantity? All right, well, the first quantity is actually our y, which is kind of tricky again, because if I asked you which one's first, all right, you would think 16 over 6, but it's our unit rate, and it is our constant of proportionality when we have a proportional relationship. All right, and remember, constant proportionality is y over x, right? And slope is change in y over change in x. But if you have a proportional relationship, those two are the same. All right, so that kind of gives the background for all of these problems we're going to be doing. So now let's just go ahead and dive in and take a look at each of these problems. All right. True or false, the table shows a constant rate of change. So if we look between these ones right here, okay, 6 to 12 is 6, 12 to 18 is 6, 18 to 24 is 6. So those are all changing by the same rate. If we go here, that's plus 16, that's plus 16, and that's plus 16. So my rate of change between each of them is 6 over 16, or if you would like to simplify it, it simplifies to 3/8. All right. By the way, they don't all have to be the same. For example, if I went from all the way to 6 to 24, all right, well, that would be what, 18. And if I went from 16 to 64, all right, well, 14 to 64, that would be 50, right? So 48. So if you looked at that one, you'd say, oh, well, that's 18 over 48. But it's not the same as 6 over 16. But if you simplify that, right, if you divide both of those by 6, what you actually get is 3/8, okay? So it's a constant rate of change if it simplifies down to the same fraction. If you get equivalent ratios, all right? So this one was easier to say yes because between every 2 points, it was the same. But I'm just telling you, like, if I took that point off, all right, between these two would be 6, and between these two would be 12. So it would look different, right? But between these two is 16, and between these two is 24. So I would get 6 over 16, and excuse me, that's not 24, that's 32. And I would get 12 over 32, and those are equivalent. So it would still have a constant rate of change. All right? But like I said, this one was really clear and easy to see because they were the same. So that's true right there, okay? If you did any of those ratios and they did not turn out to be equivalent, either the same or equivalent, the answer would be no. All right, and if, by the way, if I graph these, I would get a straight line because it has constant rate of change. All right, true or false, when a proportional relationship is graphed on the coordinate plane, The slope of the line formed by the points is equal to the constant of proportionality. The equational line passing through the points can be written as y equals kx. That is true. Remember, the slope of a proportional relationship equals k. All right? So slope equals k for a proportional relationship. And you remember the equation of a proportional relationship was y equals kx. So the equation would be y equals the slope times x. That's what it would be, again, for a proportional relationship. And just a reminder, how do you recognize a proportional relationship from a graph? This one right here would be an example. It has to have a constant rate of change. Whoops, I missed. It has to go through the origin. That one's a little better, okay? It has to go through the origin, and it has to be linear. It has to be a straight line. So this right here would be a proportional relationship. All right, and the slope would give you the constant of proportionality. All right, so again, slope is equal to rise over run, change in y over change in x, which we call rise over run. So if I take a look at this one right here, this is my change in y. How much did it go up and down? It went up and down 2. Right here, this is my change in x. How much did it go over, back and forth? It's 3. So my change in y or my change in x, my rise over run, is 2/3. Okay? Again, a lot of people put 3 over 2. Okay, but it's the y over the x, not the x over the y. Okay? All right, this one, by the way, was true. This one right here is going to be 3 over 2. No, it's not. It's going to be 2 over 3. See, I was just checking if you're paying attention. Right? Rise over run. All right, now this one right here, notice that this one is going down from left to right. It's going down from left to right. So that means it's going to have a negative slope. Okay, it has a negative slope. So immediately I know it's one of these two. All right. Now again, we're looking for change in y over change in x. Okay, so what happens here as I am going from one point to another? Now, you can use any 2 points you want to, and you can go whatever direction you want to. When it is a negative slope, I like to go down just to remind myself here. So it goes 1, 2, 3, 4. So I'm going to say that's -4, right? And then it goes over 1, 2. So my slope is -4 over 2, which simplifies to -2 over 1, which is the same as -2, right? So there's my answer. All right, and again, the great thing about slope, you can pick any 2 points. Pick any point on the line and go down 2 and over 1, and you're back on the line. Do you see that? Down 2 over 1. Down 2 over 1. Down 2 over 1. There's my slope of the line, -2. All right. Okay, moving on. Next question. What is the slope of the line in this picture? Now, this one is going up from left to right. So this one is going to have a positive slope. Now, this time they didn't give us any points, right? The one before, they gave us points to use. So I'm looking for any 2 points that are on the line, on the red line, and on that blue grid there. All right, so I'm going to pick 0, 0. By the way, that proves this is a proportional relationship because it's a straight line that goes through 0, 0. And I'm going to pick that point right there. All right, again, I could have used that point there. I could have used that point there. You can use any point you want to, but you want to make your life as easy as possible. All right, so 0, 0, if it's on the graph, is always a great one to work with. So I'm going to go from there, and then I'm going to go up, and I'm going to go over, right? So there's my rise, and there's my run. So I went up 1, 2, 3, and I went to the right 2. So my slope, again, is my change in y over my change in x. It's my rise over my run, okay? It's 3/2. up 3 over 2. And again, if I had done here, up 3 over 2, right? If I had gone from there to there, up 3 over 2. See, if you start on the line and go up 3 and over 2, you're always back on that line. If you went up 4 and over 2, you wouldn't be on the line, right? If you went up 3 and over 1, you wouldn't be on the line. The way to stay on the line is to go up 3 and over 2, because that's the slope, that's the steepness of the line. All right, so 3 over 2 is the slope. All right, and by the way, you might say 1.5, but don't say 1.5. We don't give slopes as mixed numbers. It's just so kindergartenish. All right, okay, refer to the graph below. Find the slope of the line and use it to determine the unit rate. Remember, for a proportional relationship, actually for any relationship, the slope is the unit rate. All right, the slope, that rate of change. All right. Okay, so here we go. Again, we can pick any 2 points we want to. They picked points for us, so we might as well use the points that they gave us. So if I go from that point to that point, the question is, how much did I go up and how much did I go over, right? I went up 1, 2, 3, and over 1, 2, 3, 4. So my slope, again, is my change in y over change in x. It is my rise over my run. So it is 3/4, right? Up 1, 2, 3 over 1, 2, 3, 4. All right, and what is that? It's actually what? 3 laps per minute, right? 3 laps per minute. No, it's not 3 laps per minute. Excuse me. It's 3/4 laps per minute. There we go. Okay? It's also 3 laps every 4 minutes. Right? 3 laps every 4 minutes is what it is. All right? It's also 3/4 of a lap per minute. But what did it ask us for? It asked for the unit rate. And remember, in a unit rate, that second unit has to be 1. So even though this correctly describes the relationship, this is not a unit rate, right? This one right here is a unit rate. So both of these correctly describe the graph, but this correctly describes the unit rate, because remember, it said find the slope. The slope is 3/4, so it's 3/4 of a lap every 1 minute. All right, that one's a little tricky. I think a lot of people got fooled by the whole unit rate thing. They missed that. Okay, for the table shown, time is the input, x, right? And volume is the output, y. What is the slope of the line? All right, so this is my x and this is my y. Remember, slope. You're probably getting sick of hearing me say this. Slope is change in y over change in x. It is rise over run, right? And on a table, here we go. What is my rise? Well, that's +4. That's +4. That's +4. That's +4. So they were all the same. My rise for all of them was 4. And my run +3, +3, +3, +3, right? So it's 4 over 3. Again, if I were to draw this out, it would go like this. All right, let me use a different color. So my line would be like this, okay? And everywhere on my line, it would go up 4 and over 3. That would be my point, right? So if this point right here were 3, 4, this point right here is 6, 8. To get from there to there, it went up 4, right? 4 plus 4 is 8, and it went over 3. 3 plus 3 is 6. All right, again, a lot of people made the mistake of putting 3 over 4 because that's what it looks like in the table. But remember, it's change in y over change in x, not change in x over change in y. All right, here we go. The table and the graph in the diagram below show the time it takes 2 machines to bottle milk. Refer to the diagram when answering the questions below. All right, choose the correct slope equation and unit rate for machine 1. All right, so here's machine 1 right here. So if we do what we just did, all right, if we look at the change in y, it's plus 0.6 between each of them, okay? And the change in x is plus 1 between each of them. All right, so the slope is 0.6 over 1, which is 0.6. But 0.6 is 6 over 10, right? And 6 over 10 simplifies to 3/5. So the slope is 3/5. All right? Now remember before we said that the equation for a proportional relationship line is y equals the slope times x. Well, our slope is 3/5, so it's either y equals 3/5 x, but if you look, they actually use the decimal. So what was our decimal slope? It was y equals 0.6x. So it was that one right there. All right? And then finally, the unit rate. Well, the unit rate is the same as the slope. Our slope was 3/5, so it's 3/5 of a gallon per second, right? Because that's what we're working with, gallons per second. Remember, change in y over change in x. All right, so we have this one, and we have this one, and we have that one. Those are the correct answers there. All right, which statement below is true? Since the blue line has a greater slope than the red line, machine 2 bottles milk at a faster rate. Well, it's going up steeper, right? So it's doing more gallons in the same amount of time. Do you see how the blue line is always above the red line? That means it's doing more gallons. At 10 seconds, the blue line is above the red line. At 20 seconds, the blue line is above the red line. The blue line is always above the red line except at 0, 0, because neither one's done anything. So this first one is true. Since the blue line has a greater slope than the red line, machine 2 bottles milk at a faster rate. Okay, now let's look at the next one. In 20 seconds, machine 1 will bottle 12 gallons. So let's go over to 20 seconds and then go up. Machine 1 is the red one, right? And if I go up from 20 seconds right there, and then I go over, do you see how that's 12, right? 2, 4, 6, 8, 10, 12. So in 20 seconds, machine 1 bottles 12 gallons. Well, that one is also true. Well, at that point, we've got 2 that are true, so we know that it has to be all the above. But let's just double check this last one real quick. Machine 2, that's the blue one, bottles 12 gallons in 16 seconds. So machine, if I go up to 12 gallons right here, and I go over to the blue line and then go down, I'm at 12, 14, 16. All right, so that point right there is what makes that last statement true, or shows that last statement's true. All right, the one before it was 2012. All right, so this also shows, see, for the same number of gallons, machine 1 takes 20 seconds, machine 2 only takes 16 seconds. So it is 4 seconds faster to do the same number of gallons right there. All right, so that is all of them. Look at that. We got a 10 out of 10. Good job, everybody. All right, I hope this really has helped you to understand how slope and unit rate and proportional relationships work a little bit better. So when you do the retake, you, like me, can get a 10 out of 10. All right, see you next time. Bye.